Good morning, friends. Welcome to YouTube channel Engineering Works 247. Today we are going to continue our subject RCC. Here we will discuss about some important note and assumptions in the reinforced concrete. The first is the value of AST minimum depends upon the grade of steel. For here we can say for mild steel or Fe250. Fe250 yield strength is 250 Newton per mm square. The formula for AST minimum is 0.85 upon Fy into BD or breadth into depth. After putting the value of yield strength that is Fy 250, the AST minimum we get is 0.34% of BD. Likewise for same it is for Fe415. When we put the value of Fy415 in the AST minimum formula, we get the AST minimum for the 415 grade of steel and same for 500. Here in table we can see the grade of concrete and the percentage of AST minimum required. Here directly we can see the how much percentage is required. These values are calculated by using this formula. AST minimum is equal to 0.85 upon Fy into BD. Here we can also see that as we increase grade of steel, so the grade of steel increases, the minimum percentage area of reinforcement will decrease. Here we can see here the grade of steel increases downward, the minimum percentage of area AST minimum decreases. So here is the next term maximum area of reinforcement or we can say AST max. Using according to IS code 456 2000, the maximum area should not be greater than 4% of cross sectional area or we can say 4% of BD. This condition is valid for both compression and tension. Here we can see the cross section of the beam. The top bars are known as hanger bars or we can say anchor bars. The bottom bars are known as longitudinal bars or longitudinal reinforcement, and the stirrups by which the longitudinal bars and hanger bars are connected is known as transverse reinforcement or shear reinforcement. Now we will discuss the assumptions. These play the main role in the RCC subject. The first assumption is plane section remain planes before and after bending. Here we can see, first we will see the conclusion what it states. It states that strain varies linearly. Here we can see beam or simply supported beam before loading condition. When we add UDL of W intensity over the span L, we get the deflection as you can see here. The beam get deflected in this shape. The top fiber get compressed and the bottom fiber of the beam get tension. The second assumption is maximum compressive strain in concrete shall not greater than 0.0035 under flexural condition. Here we can see the stress strain graph of the concrete. Here is the actual strength or actual graph of the concrete. And here we can see which is marked in red color characteristic compressive strength of concrete or we can say it as FCK. When FCK is divided by load factor, here we can say FCK upon 1.5. So we get the value of 0.67 FCK, which is the actual strength of concrete. And rather after dividing the partial safety factor for the actual strength, we can see 0.67 upon 1.5 to FCK. We get the 0.446 FCK value, or we can see it as 0.45 FCK, which is also known as design strength of the concrete. And we can see here the up to proof stress, the graph is changing, and up to 0.0035 it is constant. The next assumption is stress block diagram is parabolic up to 0.002. As we shown here, we can see here it's the parabolic diagram up to 0.002 strain value, and from 0.002 to 0035 it is planar. We can see it as a rectangular. The next one is all tensile stresses are taken by steel only. So tensile strength of concrete is ignored. Concrete is only used for compressive strength, the assumption states. And next is stress calculation due to concrete in tension is ignored. So concrete in tension is ignored. The fifth assumption is maximum strain in steel in tension shall not be less than 0.002 plus 0.87 Fy upon Ps at the time of the failure. We can see downward the stress strain graph for the steel. Here we can see yield strength of the steel, which is Fy, and which the strength is divided by load factor or safety factor. We can get the value of 0.87 Fy, which is also known as design strength of the steel. Here we can see as per graph strain at failure, or we can see here epsilon at strain at 0A, O2A plus strain at O2B is equal to 0.002 plus 0.87 Fy upon Es. We know that Hooke's law, which is stress is directly proportional to strain. And from graph, the value that we have obtained is strain at AB is equal to 0.87 Fy upon Es. All the assumptions are concluded in the stress diagram and strain diagram. Here we can see simply supported beam. Overall depth is D and width is B. Here we can see strain diagram. The uppermost layer is, here we can see for beam upper is compression and lower is tension. For strain diagram the values are 0.0035 and 0.002. The values we can see here also 0.002 to 0.0035, which is in second and third assumptions. And here for stress diagram we can see 0.45 FCK at the top compression member and 0.87 Fy at the bottom tension member. So thank you for today. We will discuss another part in the next lecture.